Greetings to every one of you. So in this video we are going to discuss another very important concept from data structures and algorithms, that is traveling salesman problem using dynamic programming. The problem statement is given a given list of cities and their pairwise distances are given in the form of adjacency matrix. Find the shortest possible tour that visits each city exactly once, returns to the starting city. The constraints: each city must be visited only once. Number 2, the tour must start and end at the same city. The tour must visit all the cities with minimum cost. So this is the adjacency matrix that is given, and this is the graph which represents the different cities. The salesman can travel from the city 1 to 2, 2 to 3, or 3 to 4, or 1 to 3, 3 to 2, or 2 to 4, then 4 to 1. So anyhow he can travel in any direction, but he has to follow his constraints, like each city must be visited only once, and the starting city and the ending city should be the same, and all the cities must be visited at least only once, and you should not visit already a visited city. So without violating this constraint, he has to find out the shortest route. So how to solve this problem? So one simple technique, let me represent the problem in the form of a tree structure. Then after that we move on to the dynamic programming. Let us consider the starting city is 1. Once if he selected the city 1, and the possible cities he can visit is 2, and that is another one is 3, another one is 4. So from city 2, after visiting city 2, he can select other 2 possible cities, like he can go to city 3 or city 4. Similarly from 3 he may go to city 2, or he may go to the city 4. Similarly, after visiting the city 4, he may visit the city 2, or he may go to the city 3. So the idea is he can visit the city only once. Then after visiting the cities 1, 2, 3, he can go to city 4. Then after city 4, he has to go to city 1. Similarly, after visiting this city 1, 2, 4, and he can go to city 3. After visiting city 3, he has to go to 1. Similarly, after visiting the cities 1, 3, 2, he has to go to the city 4. So from again 4 he has to go to 1. Similarly, after visiting the cities 1, 3, 4, he has to go to city 2, then again from 2 he has to go to city 1. Similarly, after visiting the cities 1, 4, 2, he has to go to city 3 and then city 1. Similarly, after visiting 1, 4, 3, he has to go to city 2, and then after that he has to go to again city 1. So this is the tree structure which represent the different the routes. Now we can calculate the cost of each path. Okay, so the distance from each city we can calculate. See, for example, let us start from the lower level, 4 to 1. So from city 4 to 1, what is the cost? So that we can indicate here. So 4 to 1, it is 8. The cost is 8. Similarly, What is the cost from 3 to 1? 3 to 1, it is 6. Similarly, 4 to 1, it is 8. Similarly, 2 to 1, it is 5. Similarly, 3 to 1, it is 6. 2 to 1, it is 5. Let us move on to the next level. So, from this level, find out the cost. From 3 to 4, 3 to 4, it is 12. But we have to add this the previous value also. So that we will get the value, that is 20. Similarly, 4 to 3, 4 to 3, it is 9. You have to add this value also. It is 15. Similarly, 2 to 4, 2 to 4, it is 10. Add the value, previous value, that is so that you will get 18. So 4 to 2, 4 to 2, it is 8. 8 plus 5, that is 13. Similarly, 2 to 3, it is 9 plus 6, it is 15. Similarly, 3 to 2, it is 13 plus 5, it is 18. Now this level is over. So now move on to the next level. So in this case, find out the distance from 2 to 3. 2 to 3, it is 9 plus it is 20, it is 29. Similarly, 2 to 4, it is 10. So 10 plus 15, it is 25. So we have to consider the minimum value, that is 25 is the actual, the minimum cost. We have to select one. Similarly, the next one, 3 to 2, 3 to 2, it is 13. And the previous cost is 18, so that is 31. Similarly, 3 to 4, it is 12. The previous cost is 13, it is 25. So comparing these two, 25 is the minimum. So 25 is the promising cost, minimum cost. Similarly, 4 to 2, 4 to 2, it is 8. It is the previous cost is 15, so it is 23. 4 to 3, 4 to 3, it is 9. The previous value, it is 18, so it is 27. So comparatively, 23 is the minimum value, so that we can consider, that is the cost of reaching this city. Now come to the first level from city 1. From city 1 to reaching, that is city 2. 1 to 2, it is 10. We have to add this value, that is 25, so that is 35. The second city, that is the third city, that is 1 to 3. 1 to 3, it is 15. The minimum cost value, it is 25, so it is 40. The total cost is 40. Similarly, from city 1 to 4, 1 to 4, it is 20, and its minimum value, it is 23, so which is 43. So now we have to, that is, compare, and you have to select the minimum value. So every stage we are taking only the minimum value. So once if you compare all the three, and you can find that this 35 is the minimum cost. So the minimum cost, we have to select the path, like this is the path, so 1 to 2, and again this is the minimum value, minimum cost, and similarly there is reaching 1. So this is the route. Okay, so that is 1 to 2 and 2 to 4, then 4 to 3, and from 3 to again that is 1. So that is the tree representation. This method is what is called a brute force method. So now come to this dynamic programming. So what is dynamic programming? So dynamic programming, in which a given problem is splitted into the small problems. Step by step we will get the solution, and we will take the decision whether that particular decision, whether particular solution is good or not. Combining all these solutions and finally just arriving the resultant solution, that is what is called dynamic programming. So this is the general formula. This cost of this city, that is the initial city, and remaining the set of the cities, the minimum, and the specified city, that is K, is a subset of this cities S. We have to consider the minimum value. The cost of reaching I2, that is K, plus cost of reaching K2, the set of cities, that is eliminating this K, because K is included here. So this is a general formula, and this can be, that is applied for our example, our problem, like cost of reaching, that is from city 1 to the remaining set of cities, that is 2, 3, 4, and the minimum value, that is K, is a subset of this 2, 3, 4, and finding out the minimum value from this C 1K plus this one is the starting city 1K, and cost of K to reaching the other cities, that is 2, 3, 4 minus this K. Now let us calculate the cost, the step by step. Okay, the cost of reaching from city 2 to 1, it is 5. Similarly 3 to 1, it is 6. Similarly 4 to 1, it is 8. So this you can write it from the adjacency matrix also. That is the cost of, that is 2 to 1, and similarly 3 to 1, and similarly 4 to 1, that is 5, 6, 8. Similarly come to the next level. So reaching from 2 to 3, we have the value, that is 15. Similarly 2 to 4, the value is 8. Similarly cost of reaching 3 to 2, it is 18. Okay. Similarly cost of reaching from 3 to 4, it is 20. Similarly cost of reaching 4 to 2, it is 13. Cost of reaching there is 4 to 3, it is 15. Okay. So after finishing this level, we'll come to this level. Okay. From that is 2 to 3, 4. 2 to 3, 4, the minimum value already we have calculated, 25. Similarly cost of reaching 3 to 2, 4, we have to consider the minimum value, that is also 25. Cost of reaching, that is 2 to 3 from that is 4, that is 23. So these are the different the steps, different solutions at different levels. We have to, that is use all these values in the final equation. So cost of reaching, that is 1 to the remaining cities, that is 2, 3, 4, and we have to take the minimum value of that is cost of, that is 1 to 2. What is the cost of 1 to 2? Reaching from 1 to 2, that is 10. So this is 10. What is the cost of reaching 3 to 4 from 2? That we can take it from here. It is 3 to 4 from 2, that is 25. Comma. Cost of reaching 1 to 3. 1 to 3, it is 15. Plus cost of reaching 2 to 4 from 3, it is 25. So just I am writing the values only from this the previous solutions. All these are the step by step solutions. Okay, so that is dynamic programming. Similarly, comma, cost of reaching, that is 1 to 4. 1 to 4, it is 20, and cost of reaching, that is 2, 3 from 4, it is 23. Now just perform this addition. It is 35, it is 35, 40, 43. So we have to consider the minimum value of this. So the minimum value is 35. So our solution, the answer is 35. And of course the given root already we have calculated. From there is 2, 1 to 2, then 2 to 4, 4 to 3, and then 3 to, that is 1. So now we got the solution, that is the 35 is the minimum cost, and this is the actual the root which yield this value. I hope you understood the concept. So in this video I have explained what is a traveling salesman problem, and also I explained how to solve a problem. Keep watching. Thank you.